everyone, and welcome back. Credits Gustavo Gomez as both the producer
Oh, wow.
and the director.
Yeah.
Okay, so, it's interesting because we have this, this really kind of clash of topics are we alone in the universe? Are there other planets like ours?
Right.
Exoplanets and habitable zones, but
Yeah. No, it's fascinating.
we're gonna find those connections, I promise.
Oh, absolutely.
By the end of this, you'll see how everything kind of ties together.
Yeah, I think at the heart of it is this human need,
Yeah.
this drive to kind of explore and figure things out.
To understand.
Whether it's,
Yeah.
Baking a simple cake
Yeah.
or, grappling with the biggest questions of existence.
Absolutely, and you, our listener, have given us quite the
mix.
Quite the mix to work with today.
Yeah.
We've got a transcript from a History Channel documentary
Oh, cool.
that really digs deep into the search for Earth-like planets.
Oh.
And it's pretty exciting stuff. They're talking about how close we might be to actually answering that question, are we alone? And just to throw one more thing into the mix,
Okay.
there's this Fox Business segment about potentially unsealing classified files
Interesting.
related to some pretty major historical events. So, yeah, it's
a range.
a pretty wide range of information.
For sure.
And the goal today is to kind of find the connections between these things.
Yeah, pull out the insights.
Pull out the insights and give you that shortcut to understanding.
Yeah, I like it.
So you don't have to, wade through all the details yourself.
Perfect.
Okay, so let's start with something easy, this big time here, and talk about this History Channel documentary
Okay.
and their exploration of exoplanets.
Awesome.
So right off the bat, they ask this really big question.
Yeah.
Are we alone?
It's the question, isn't it?
It is the question.
You look up at the stars and you wonder,
Yeah.
Are there other beings out there
Yeah, looking back at us.
asking the same question?
Exactly. And the documentary even mentions how this question,
Right.
it's been around for as long as humans have been around.
Yeah, our ancestors were asking this.
Totally. They probably sat around their fires and looked up at the stars.
And wondered about those distant campfires.
Yeah, exactly. And what's really cool is that the narrator says
Yeah.
that we are on the verge
Oh, wow.
of having the technology to potentially answer that question
On a lifetime potential.
in our lifetime.
That's amazing.
No, it's a huge thought.
It really is. It's like we're moving from speculation to the possibility of actual knowledge.
I know. It's exciting.
So exciting.
So let's say we do find another Earth.
Okay.
What are we even looking for?
Right. What does that even mean?
What would make a planet another Earth?
Yeah.
This scientist, Victoria Meadows, she lays it out really clearly.
Okay.
She says that for life as we know it, you need three basic things.
All right.
A liquid medium.
Okay.
And water is probably the most likely one since it's so common.
Makes sense.
Then you need the basic building blocks of life.
Okay.
Like phosphorus, which is super important for DNA.
Right.
And, of course, you need some source of energy.
Gotta have energy.
Yeah. And she mentioned something really important.
What's that?
If you find a rocky planet
Okay.
with liquid water on it,
Mm-hmm.
it's very likely that it also has those other essential ingredients for life.
Oh, that's interesting.
But here's the thing. It doesn't have to be an exact copy of Earth.
Ah. Okay.
Life might exist in all kinds of different environments.
That makes sense.
And Victoria Meadows uses this really cool analogy.
I love a good analogy.
She says, imagine all the different kinds of houses in a city.
Okay.
You've got your grand mansions,
Yeah.
your modest homes, tiny studios,
Right.
and towering skyscrapers.
Oh, okay.
They're all places where people live.
Yeah, different kinds of dwellings.
Right. And in the same way, there could be all sorts of different planets.
Yeah, with different characteristics.
Exactly.
That could still support life.
It doesn't have to be Earth 2.0.
Right, broadening our perspective.
Exactly.
Very cool.
And, we've already found over 300 exoplanets.
Wow, that many.
I know. It's crazy, right?
Yeah.
But the problem is most of those are gas giants. They're huge, and they're easier to spot.
That makes sense.
Because, our technology right now is better at detecting those really big planets than those smaller rocky ones that might be more like Earth.
Oh, okay. So how do we find those smaller planets then?
Well, that's where places like Victoria Meadows Virtual Planet Laboratory come in.
Oh, tell me about this.
It's at the University of Washington.
Okay.
And they're doing some really cool work.
What are they up to?
They're basically building simulations
Ah, okay.
of planets and environments.
So virtual planets.
Yeah.
Cool.
Before we've even seen them for real.
Oh, so they're trying to predict what these planets might be like
Yeah, they're kind of...
before we even find them.
Yeah, like a sneak peek.
That's amazing.
Right, so they can model all kinds of crazy scenarios.
Like what?
Like, imagine a planet like Earth,
Okay.
but orbiting a star that's much hotter
Okay.
and blasts out way more ultraviolet radiation.
That sounds intense.
It would be a totally different world.
I bet.
And they can figure out what kind of life might survive in those conditions.
That's so cool.
And you know what else?
What?
These simulations show that plants on other planets might not even be green.
What? No way.
Yeah, so around stars that are hotter and bluer,
Okay.
like F-type stars,
Uh-huh.
the plants might absorb more of that blue light
Okay.
and reflect back reds and oranges and yellows.
Whoa. So alien landscapes could be totally different colors.
I know, right?
That's mind-blowing.
And around those cooler, redder stars.
Like the M-type stars.
Yeah, the plants might be black.
Black plants.
Yeah, to soak up as much of that limited light as possible.
Wow. Nature is so adaptable.
It really is. And the documentary also talks about this crazy idea
Okay.
of a water world orbiting a really volatile M-type star.
Okay.
And because of these intense flares from the star,
Yeah.
life might exist underwater.
Underwater.
Yeah, like 9 meters deep or something.
That's deep.
To be protected from the flares,
Okay.
but still get enough light for photosynthesis.
Wow. So life could exist in places we never even imagine.
Absolutely.
That's incredible.
Okay, so how do we actually find life on these faraway planets?
Yeah, that's the question.
Well, the main thing they're looking for is what they call byproducts of life.
Byproducts of life. What does that mean?
So basically, certain gases
Okay.
that are released by living things.
Oh, so like we could detect life by the gases it produces.
Exactly. The narrator even says, life stinks.
Oh, I see.
And it's true because, biological processes
Yeah.
often release unique combinations of gases.
Right.
And scientists can analyze the light
Okay.
that passes through a planet's atmosphere
Uh-huh.
or is reflected off of it
Okay.
using these super sensitive instruments called high-resolution spectrometers.
Wow. So they're looking for the fingerprints of life in the light?
Yeah, exactly.
That's fascinating.
One of the key concepts in the search for life is the habitable zone.
Oh, yeah, the Goldilocks zone.
Right.
Not too hot, not too cold.
Exactly. And this astronomer, Jeff Marcy, he's really well known for discovering exoplanets.
Uh-huh.
He explains that the habitable zone
Yeah.
is the region around a star where the temperature is just right
Yeah.
for liquid water to exist.
Right. Liquid water is essential for life as we know it.
Exactly. He says, show me the water.
Love that quote.
I know, right?
Simple but powerful.
And here's the thing. The habitable zone isn't fixed.
What do you mean?
It changes depending on the star.
Oh, okay.
So hotter stars have their habitable zones farther out,
Yeah, that makes sense.
and cooler stars have them closer in.
Right, because the temperature has to be just right.
Exactly. And even our sun's habitable zone
Uh-huh.
will move outward over billions of years as the sun gets hotter.
So the habitable zone isn't static?
Nope, it's always changing.
That's really interesting.
And since we can't travel to these exoplanets yet,
Right.
astronomers have to get creative.
Yeah, how do they study them?
Well, they use our own sun
Okay.
as a reference point.
Oh, interesting.
It's like a proxy for understanding what those distant systems might be made of.
So they're using what we know about our sun
Yeah,
to infer things about other stars.
exactly. Because stars and their planets
Mhm.
form from the same cloud of gas and dust.
Right.
So if you study a star,
Uh-huh.
you can get clues about the planets orbiting it.
Makes sense.
They do this by breaking down the starlight
Okay.
into its different colors
Yeah.
and looking for missing wavelengths,
Okay.
which act like fingerprints
Oh,
where
cool.
the elements present.
So it's like a chemical analysis of starlight.
Yeah, exactly. That's amazing.
And the goal is to eventually do this directly for exoplanets
Oh, wow.
using future telescopes.
So we could analyze the atmospheres of other planets?
Exactly. And identify things like oxygen, water vapor,
Mhm.
ozone, carbon dioxide, nitrous oxide.
All the signs of potential life.
Exactly.
That's so cool.
And Victoria Meadows reminds us
yeah.
that we can't limit our search to planets with atmospheres just like Earth. Right, because Earth's early atmosphere
Yeah.
was very different from what it is now.
Exactly. So there can be all sorts of,
Right.
strange and different...
Habitable worlds
Exactly.
that don't look like us.
Now, the documentary also touches on this question
Yeah.
of intelligent life.
Okay.
And they talk about the Drake equation.
Ah, yes, the famous equation.
Yeah. It was created by Carl Sagan and Frank Drake.
Yeah. Those are big names.
Yeah. And it's this attempt to estimate
Okay.
the number of intelligent civilizations
Right.
that might be out there in our galaxy.
So how many other civilizations could there be?
Well, the Drake equation
Yeah.
takes into account all these different factors,
Okay.
like the rate of star formation.
Mm-hmm.
How many of those stars has planets?
Right.
How many of those planets could support life?
Yeah.
And so on.
And what were the results?
Early estimates were really optimistic.
Oh, wow.
They suggested there could be hundreds of thousands,
Wow.
maybe even a million.
A million other civilizations.
It's mind-blowing.
That's a lot of potential pen pals.
I know, right?
So are we sending out signals?
Well, that's a whole other conversation. But then the documentary presents this more kind of,
Realistic view.
realistic view
Okay.
called the rare earth hypothesis.
Okay, what's that?
So it's mainly argued by these two guys,
Okay.
Peter Ward and Don Brownlee.
Uh-huh.
And they wrote this book.
Okay.
And they basically say that while simple life
Yeah.
might be pretty common out there,
Or?
complex life, like animals and intelligent beings,
Right.
could be extremely rare.
Oh, so we might be unique.
Yeah, potentially.
Wow, that's a big thought.
It is. And they point to several reasons for this.
Like what?
One key thing is plate tectonics.
Oh, interesting.
So plate tectonics basically act as a thermostat for the planet.
Okay.
They regulate the temperature over long periods,
Right.
and they recycle elements,
Yeah.
which are essential for life.
So without plate tectonics,
Yeah.
a planet might not be stable enough for complex life.
Exactly.
Interesting.
They also talk about the importance of heavy elements,
Okay.
what astronomers call metals.
Mm-hmm.
These are any element heavier than hydrogen or helium,
Okay.
and they're necessary for building complex life.
Right.
And guess what?
Well,
Plate tectonics are responsible for bringing those elements to the surface.
so it all ties together.
Yeah, it
Mhm.
does.
Cool.
And then they have this idea of a good Jupiter.
The good Jupiter.
Yeah, so Jupiter is this massive gas giant in our solar system,
Right.
and it's really good at deflecting asteroids and comets.
Oh, so it's like a shield.
Exactly. It protects the inner planets
Oh, wow.
from getting bombarded by space rocks.
So we need a good Jupiter to protect us.
It definitely helps.
Fascinating.
And they even joke that Jupiter, maybe failed on the job.
Oh, right.
The dinosaurs got wiped out.
That's one way to put it.
And their argument goes even further.
Okay.
They say that it's not just about being in the right spot around your star.
Right. The habitable zone.
It's also about being in the right part of the galaxy.
The galactic habitable zone.
Exactly.
So there's a good neighborhood in the galaxy.
You could say that.
Okay.
You want to be away from the center of the galaxy,
Yeah.
where there's a lot of radiation and other dangers.
Makes sense.
And you also want to avoid things like killer neutron stars.
Killer neutron stars.
Yeah.
That sounds bad.
They're not very friendly.
And black holes.
And black holes and gamma ray bursts.
Yeah, those are all pretty intense.
And they actually mention this scary event.
Oh.
Back in 1998,
Okay.
this magnetar,
Yeah.
which is a supermagnetic neutron star,
Yeah.
it blasted out this huge burst of gamma rays.
Whoa.
Luckily, it was far away,
Okay.
like 20,000 light years.
That's still pretty far.
Yeah. But they say that if something like that happened
Yeah.
much closer,
Mm-hmm.
it could literally rip our atmosphere off.
Seriously.
Yeah, it's pretty terrifying to think about.
Yeah, that would be a bad day for Earth.
So the rare earth hypothesis,
Yeah.
it kind of makes you think that maybe we are just a fluke,
Yeah.
a cosmic
It's
accident.
a 1 in a billion chance.
And if that's true,
Yeah.
we might be the only ones out there,
The only intelligent life.
at least in our corner of the universe.
That's both exciting and a little lonely.
I know, right?
It's like we have this huge responsibility to explore and understand.
Yeah, and to take care of our planet.
Absolutely, because it might be the only one like it.
And even if there are tons of Earth-like planets out there,
Right.
it is really hard to find them.
Yeah, we were talking about that earlier.
It's tough because they're tiny
Yeah.
compared to their stars.
Right, like that firefly next to a lighthouse.
Exactly.
Yeah.
And not only that, but you have to analyze their atmospheres,
Yeah, to look for those signs of life.
which is incredibly difficult.
Right.
So astronomers have had to come up with some clever techniques.
Oh, like what?
Well, one of the main methods is called the transit method.
Okay, I've heard of that.
So basically, they watch a star
Okay.
really carefully,
Yeah.
and they look for any dips in the star's brightness.
Okay.
And those dips
Yeah.
could indicate that a planet is passing in front of it.
Oh, so it's like a mini eclipse.
Exactly.
Ew.
And by measuring how much the light dips,
Yeah.
you can figure out the size of the planet.
Oh, so the bigger the dick,
Yeah,
the bigger the planet.
exactly. And by looking at how often those dips happen,
Mm-hmm.
you can figure out the planet's orbit.
Okay.
And if you know the star's temperature,
Right.
you can estimate if that planet is in the habitable zone.
Oh, that's clever.
It is.
It's like detective work.
It really is.
Using light to uncover secrets.
Absolutely.
I love it.
And then there's another method called the radial velocity method.
Okay, what's that one?
So this one detects the wobble of a star.
Low wobble.
Yeah. Because the planet's gravity
Okay.
tugs on the star a little bit.
Right.
Make it wobble ever so
I
slightly.
see.
And that wobble
Yeah.
tells you about the mass of the planet.
Oh, so the bigger the wobble,
Yeah.
the more massive the planet.
Exactly.
Cool.
And when you combine data from both methods,
Yeah.
the transit and the radial velocity,
Uh-huh.
you can get a really good picture of the planet.
Oh, wow.
Its size, its mass, its density.
So you can tell if it's rocky, like Earth,
Exactly.
or a big gas giant.
Yeah, and this is where you see those connections again,
Oh, yeah.
like with the cake recipe.
Okay.
Scientists are using these really precise measurements
Yeah.
and careful analysis
Sure.
to figure out what these planets are like.
Just like a baker following a recipe.
Exactly.
That's a cool way to look at it.
And one interesting thing they found
What's that?
is that stars with more heavy elements,
Okay.
what astronomers call metallicity,
Right.
are more likely to have planets
Uh-huh.
with lots of heavy elements too.
Interesting.
So basically stars that formed from clouds with more building blocks
Yeah.
tend to make more substantial rocky planets.
That makes sense.
And when it comes to habitable planets,
Right.
size really matters.
Oh.
The planet needs to be big enough
Yeah.
to hold on to its atmosphere
Mm-hmm.
and to have things like plate tectonics and volcanoes,
Right.
which help regulate the temperature.
So it's a Goldilocks situation again?
Totally. Not too big, not too small,
Yeah.
just right.
Just the right size.
They estimate that a habitable planet
Yeah.
would be somewhere between 1/3
Okay.
and 10 times the mass of Earth.
That's a pretty wide range.
It is,
Yeah.
but it gives us a starting point.
Right.
And early on in the search for exoplanets,
Yeah.
they found these things called hot Jupiters.
Hot Jupiters. What are those?
So they're gas giants,
Okay.
but they orbit incredibly close to their stars.
Oh, so they're like superheated gas giants?
Yeah, exactly.
That sounds intense.
And this discovery was really surprising
Really?
because it showed that planetary systems
Yeah.
can be really dynamic
Okay.
and that these massive planets
Yeah.
can migrate inwards.
Oh, so they don't always form where they end up.
Right.
That's interesting.
And unfortunately,
Yeah.
this inward migration
Uh-huh.
can be really bad for smaller rocky planets.
Yeah. Oh, how so?
Well, they can get flung out of the system completely.
Oh, no.
Yeah.
So a hot Jupiter in your neighborhood is bad news.
Pretty much.
If you're a small rocky planet.
Yeah.
Okay.
The documentary gives a few examples
Oh, cool.
of early exoplanet discoveries
Yeah.
and why they weren't quite another Earth.
Okay.
So there was 51 Pegasi b,
Yeah.
which was the first exoplanet ever found
Wow, the first one.
around a sun-like star.
That's a big deal.
It was a huge discovery.
So was it Earth-like?
Not even close.
Oh.
It's a scorching hot gas giant.
Oh, bummer.
Yeah.
So what about the others?
Okay, then there was 70 Virginis b,
Okay.
which was actually nicknamed Goldilocks.
Oh, because it was in the habitable zone?
Yeah, initially they thought it was in the sweet spot,
Uh-huh.
but it turned out to be a massive gas giant with a really weird orbit
Okay.
that would make the temperature fluctuate wildly.
So not very habitable.
Not at all.
Okay.
And then there's Trieste-4.
Trieste-4.
Yeah.
It holds the record for the largest planet found so far.
Wow. The largest one.
But it's incredibly lightweight for its size.
That's weird.
I know, it's a real oddball.
It's like a giant puffball.
Exactly.
So what about planets that are closer to Earth in size?
Well, there was Gliese 581c,
Okay.
which they thought might be Earth-like at first,
Uh-huh.
but it's now thought to be more like a super Venus.
Oh, so way too hot.
Way too hot.
Okay.
However, its neighbor, Gliese 581b,
Okay.
which orbits a bit farther out,
Uh-huh.
might actually be habitable
Really?
if it has a thick enough atmosphere
Okay.
to keep it warm.
So it would be on the colder edge of the habitable zone.
Exactly.
Interesting.
And then there's HG 69830d.
Okay.
It has a potentially good temperature,
Uh-huh.
but it's 17 times the mass of Earth.
Oh, wow. So probably not rocky. Yeah, it's probably more like a mini Neptune.
Oh, okay.
And you see, it's a real process of elimination.
Yeah, lots of trial and error.
Yeah, and every new exoplanet we find
Hooray.
helps us refine our search.
To get closer to finding a true Earth twin.
Exactly.
That's exciting.
And what about planets closer to home?
Oh, yeah, in our own solar system?
Yeah, like Venus and Mars.
Right.
They're kind of like failed Earths.
Failed Earth.
Yeah, they're right on the edge of the habitable zone,
Okay.
but things didn't quite work out for them.
Oh, so what happened?
Well, Mars is too small.
Okay.
It couldn't hold on to its atmosphere,
Right.
and it doesn't have plate tectonics,
Yeah.
so it couldn't recycle those important
Makes
elements.
sense.
And Venus is the opposite problem.
Okay.
Too close to the sun,
Uh-huh.
and it has a runaway greenhouse effect.
Oh, no.
Too much carbon dioxide in its atmosphere.
Right.
So it's super hot.
It's like a furnace.
One scientist even says that Venus was born in the wrong place,
Okay.
and Mars was born the wrong size.
Oh, so Earth really is in the sweet spot.
Yeah, it seems like we got lucky.
Wow.
But what about our closest neighbor?
You mean Alpha Centauri?
Yeah,
Okay.
it's a system with two sun-like stars.
I know I've heard of that one.
And it's pretty close to us.
Yeah, relatively speaking.
And they've found that it has a high metallicity.
Oh, so lots of heavy elements.
Yeah, exactly, which means there's a good chance
Yeah.
it has rocky planets.
That's promising.
It is. And here's the best part.
What's that?
There don't seem to be any Jupiter-sized planets.
Oh, that's good.